Hi guys, Mr. T again here, and we're ready to do part 3 of our statistics little videos here. Again, statistics is a means of collecting and organizing and understanding different types of data. And we did the types of sampling and difference between an observation study and an experiment. And then we've talked about normal curves. And today we're going to talk about margin of error. Yes, indeed, margin of error. Okay, everybody's favorite subject. Doesn't everybody like to say, "Hey, this is where I did wrong"? No, this is not what we're talking about. It's margin of error. Um, and so we have some formulas, and of course, we always want the margin of error to be small. Why is that? Well, let's just think about this. So we've been collecting this data, and we're going to use this data to make a prediction. So let's say I collect data about all the heights of people in all my classes. And so, based on that, I'm going to make a prediction that if I randomly picked any one of my students, they're going to be um, 5'8" with a margin of error of 2 inches. Okay. So, what does that mean? If I make a prediction that if I randomly picked a student, I'm going to say that they were going to be 5'8" with a margin of error of 2 inches. What that would mean is if I take 5'8" plus 2, or 5'8" minus 2, so that's plus or minus 2. So as long as I picked a person who was anywhere between 5'6" and 5'10", I would say that I did a good prediction. So that's the kind of margin of error. So that's a small. But what would you say if I said the same thing and said, okay, I'm going to make a prediction of how tall a student is if I randomly pick one, and I'm going to have a margin of error of 10 inches. Well, if I say 5'8", give or take 10 inches, so let's add 10 to that. What's that? 5'8" plus 10. Well, that'd be like 6'8". And then 5'8" minus 10, that'd be 4' 10 inches. That'd be, with that kind of margin of error, that would include everybody. How good of a prediction is that? Well, if I allow that much error, it basically covers my tail for everybody, doesn't it? But that's not really good predicting. It doesn't really show that I have gotten a lot of good statistics. I don't really know what's going to happen because it's too big of a range. So that's what the idea of margin of error. So when you see plus or minus, what they're meaning is when I make a prediction for a certain thing, as long as I'm within plus or minus of that number, I'm going to say that's as accurate as I can be given the data I have. That's the concept. So we got a couple of formulas here. You're going to have to memorize them. And these are really, really, really simple concept margin of error formulas. If you're going to do real margin of error, more detailed stuff, you're going to need something a little bit more complicated than these. But these are introductory concepts in which you would get a margin of error. Okay. So first, it's got mo, the big mo. Okay, the big mo margin of error is what we're going to do is going to do plus or minus 1 over the square root of n, and n is the total population. Population, that means if I go out and interview 10 people and get the survey with 10 people, my margin of error would be 1 over the square root of 10. Okay, 10 is probably not a very good number, a pretty big margin of error, don't you think? Sure enough. But it would be my prediction plus or minus whatever that number would be. So n is the number, is the population. Okay. Well, so that's a really, really simplified. So the concept here is though the more people I survey, the smaller the margin of error should be, right? But what about it? There's another way we could rearrange this. If I squared both sides and did some, work on that, we could rearrange this and get a slightly different formula here. Okay, this one is I already know the margin of error, and I want to know how many people I surveyed. What is the total population? So if I have a margin of error, something I could plug it here. So take the margin of error, square it, 1 over that, and that will give me my total population. It's the same formula, actually, just rearranged. Okay. And me personally, the one I memorize is this one because this one seems to make more sense. It's the population 1 over mo squared, and I can always figure out the other one from that information. Because I like to memorize one thing that can work for both. But those are the two versions that we're going to be looking at. So let's start with doing margin of error. And we're going to use this version, this formula to do so, okay? So in our little packet here, it says find the margin of error for a survey that has the given sample size. That means how many people were surveyed. Round your answer nearest 1/10 of a percent. Okay, so here we go. We're going to do, here's our margin of errors. So that's going to give us mo equals plus or minus 1 over the square root of 200. Okay, so what does that look like? Well, let's jump over here to my calculator. So we're going to do alpha there, get my fraction going up, and it's 1 over, let's see, the square root of 200. Okay, and I get 0.071. 0.071. So this is equal to 0.071, but they said they wanted to be to the nearest 10th percent. So we're going to pull this over 2 places, and that's going to end up being plus or minus 7.1%. Okay. So 7%, how good is that? Well, it kind of depends on what the situation. Sometimes 7% is good enough, but generally I would say it's not really good. Okay, and so you would do that with all of these. That's the whole point. Let me pick out one more here. Let me try 6 here. Okay, it's a pretty big number. It's a bigger number, and so I'm going to suggest that when we do this bigger number, that number percentage should go down. Okay, so we're going to use our formula. I'm going to write that, of course. Mo equals plus or minus 1 over square root of 1,100. I'm going to grab my calculator real quick. Second, enter, and then just come back over here. Just do 1100, enter, a 0.030. Okay, so that equals 0.030, and then when I change that over to a percent, okay, it's going to equal plus or minus 3%. 3%. Okay, so that's the idea. The higher the sample size, the lower the margin of error. Okay, so now let's go to the next section here. Whoops, did I skip something here? Yeah, I got these out of order. There we go. This section here, it says I'm going to give you the margin of error, and I want to know how much is the sample size, the total population. So we're going to do it the other way around, and they want us to round this to the nearest whole number. Okay, so we got n equals 1 over 0.02 squared. Okay, 0.02 squared. So let's put that in our calculator real quick. One over 0.02 squared. Enter. 2,500. Okay, so our n is equal to 2,500 people. That's the deal. Okay, let's do one more here. Let's do 16. Let's do, well, no, let's do 14. Okay, that'll work. It's over here. Got more room to work. So n equals 1 over, gotta move this over 2 places to the left, so that's going to give me 0.095 squared. Okay, so back over to my calculator. I'm just going to copy that back over here. I can't get in here. It's 9.5. And okay, so it's 110.803. So that's 110.803. And they said to do what with this? Round it to the nearest whole number. So we're going to say that's 111. Okay. So they only surveyed 111 people. Okay. So that's margin of error when they give you the sample size and you figure out the margin of error, or they give you the margin of error and you got to figure out the sample size. Just a couple, let's look back over here real quick. So a couple more examples. So we got a survey of 504 people in the United States. About 11% said that the influx of new technologies such as computers has left them feeling overwhelmed. Okay, so a simple margin of error is so what's that formula for margin of error? Margin of error equals plus or minus 1 over the square root of n. So what we would do there is do margin of error. Oh, goodness gracious, let's get rid of that. Margin of error equals plus or minus 1 over the square root of 504. And then you would finish that out, rounding your numbers. Now it says give an interval that is likely to contain the exact percent of people in the United States who feel overwhelmed. Well, let me go back. I'm going to finish that off, I'm going to actually need to know this number. So let me figure that out. Oh, 4. Okay, so we're going to have 0.045. Okay, which is I'm sorry, plus or minus 4.5%. So what we're going to do is we're going to take this 11% that we said about this, and so we're going to say it could be 11 plus, plus 4.5%, or 11 minus 4.5%. And so, and those two things right there will give you an interval. So from here to there, that you're going to be able to work within. So we're predicting that it's going to be 11%, but with a 4.5% error, it could really be 15.5% or something less than that. So that's how that would work. Let y'all finish that off. And then we got this one more guy here. See if I can give you a hint in the right direction. He's got a survey of 510 kids, so that's our N, our sample size, ages 8 to 18. I'm not sure if that means anything. And then 68% of those surveyed have TV in their bedroom. Okay, so how many kids 8 to 18 were surveyed? 510. What's the margin of error? Well, you're going to do plus or minus 1 over the square root of 510. Okay, give the interval. Okay, so we're going to take that and add it to 68% and subtract it. So we're going to add that number to 68 and subtract it, and that will give us our interval for that deal there. So just a quick brief look at very simple formula for margin of error. Okay, so slide back here. So plus or minus 1 over n, which is the total population or sample size, or you know the margin of error and you're going to figure out what the number of the sample size was. Okay, as always, hope that was helpful, and y'all have a great day.